Hello. In this video we are going to show the most essential of System Tuner Studio, starting with an example that is as simple as possible. System Tuner Studio, STS, is a tool used to optimize any system, be it electronic, mechanical, optical or any other type, as long as its operation can be described numerically. STS has three fundamental cores. The first contains the system description. The second contains the function that allows us to numerically describe how well the system behaves, as well as other optional things. And the third is the one used to optimize the system. The example we have chosen is very simple. How to make a box without a lid, 1 cubic meter, with a minimum amount of cardboard. Let X, Y and Z be the dimensions of the box, then the area of cardboard used is given by the following formula. The volume of the box is as follows. Then, eliminating Z, we obtain the area to be minimized as a function of the variables X and Y. Since for System Tuner Studio, the system is better the higher the figure of merit, we can define it as a constant divided by the area. Then, from the STS point of view, the system is determined by the parameters X and Y that have to be determined, and the volume, that is equal to 1. And the figure of merit by the formula obtained above. This problem is easy to solve numerically, and the answer is that X must be equal to Y and equal to the cube root of 2. Let's see how to do it with System Tuner Studio. First, the system is edited. The X and Y parameters are added to the related parameters list. In this list, the adjustment parameters, and those that are numerically related, are entered. Arbitrary values are assigned to them. In the code column, simply enter the return statement, because in this case there is no dependency of one parameter on another. In the independent parameters list, the volume is added, since this parameter will be kept constant during the optimization. Save and compile. The figure of merit editor is opened. Here we see that by default 3 regions are pre-edited that should not be modified, in 2 regions in which the code of the project to be programmed is entered. Variables X, Y and V are declared. The system is asked for their values, which is done through the getParameter method, which can be searched among the frequently used methods. Notice that the first argument of the method is the name of the parameter, which was assigned to it during the figure of merit editing, and the third is the name of the variable that was declared previously. The second is not modified. The figure of merit code is added. Finally, the text that we want to show during the optimization is programmed. In this case it would be the values of X, Y and Z, as well as the value of the total area of cardboard used. Once the addition with the code editor is finished, the code is sent to the parent dialog, and it is saved and compiled. The third core, the tuner, is opened. The system, previously programmed, is loaded. And the ranges in which we are going to allow the adjustment parameters x and y to move are introduced, as well as the partition dimension for both parameters. Then, the previously programmed figure of merit is loaded, and in a few seconds results are obtained. The optimization control indicates that the optimal values are in the green zone. During the calculation of this control, the cursor is positioned at the point with the highest figure of merit. In this case, the values obtained are the following. As we can see, they are very close to what is expected, but not exactly. This depends on how fine the selected partition is, but if you wanted to improve the result, click on the Tune menu item and a perfect match is achieved. Even when the result has already been obtained, the transformation of the box can be visualized during the optimization process. To do this, a few more lines of code have been added to the figure of merit. A set of points, associated with the vertices of the box, is added. Then an array is created that is passed to the GR object in charge of drawing the box. Finally, a transparent array is created to fix the coordinates of the axes. Now the project is created replacing the previous figure of merit code with this one. And you can see the variation of the dimensions of the box, according to the position of the cursor in the optimization box. The optimization will take us to the same point where the area is minimized. Automatic cursor movements can also be applied. Much more complex projects, of course, can be programmed. Sophonia's team will appreciate your comments. Thank you for your time.